We just learned log laws. Oops, simplify using log laws. How do you know when you're done simplifying with log laws?
When there's only one.
You have one log left all by itself. Well, what happens at this step is we need to get rid of the log. What's the only thing that we know that can just make a log disappear? Convert to exponential form. At that point, we'll be able to solve it just using our normal equation solving techniques. And the last step's going to be in red. And it's going to be check. Well, just going back to, oh, I deleted it, crap. Those three special equations we looked at before. What's special about a radical? What can you not have, or what kind of numbers make it not work? Negatives under that square root. And absolute values? So you get extraneous roots and absolute value when you check it and the right-hand side comes out to be negative, because absolute value can't be negative. What about with rationals? 0 on the bottom. Okay, you know with logs, what can we not take the log of? What kind of numbers? Negatives and 0. Why? Because there's no exponent that will give us a negative or a 0. So check logs cannot be 0 or negative. And this is called extraneous roots. See, you find something that rhymes with extraneous. Okay, well, maybe it's that easy. Shut up. What I love about these is, well, I love solving equations in general, but these steps are going to work every single time. So there's no really kind of exceptions. There's no quirky ones. These are going to be the same steps every time. Logs on one side, numbers on the other. Simplify using your log laws. Convert to exponential. Solve. Check. Okay, so grab your paper, example number 1. Okie doke. So we've actually done these before, simple ones like this, without having to go through these steps. We're just going to show that for something simple, the same steps are going to work. So step number 1, logs on one side, anything without a log to the other. Done. Simplify using log laws. How do you know when you're done simplifying? 1 log. Done. Convert to exponential. What moves? 2 goes over, bumps the 3 up. Log disappears, so x equals. And that's a value, x equals 8. So we check it really by not writing anything out. We just take that value, we stick it back in for x, and we just double check that it's not negative or 0. Well, this one, it's 8. It's clearly not negative or 0. So the answer's good to go. Okay, let's step it up and do one that we couldn't do just in our head before. So 5 equals log base 2x plus log base 2x. Okay, logs on one side, numbers on the other. Done. Simplify using log laws. So the homework the past couple days just looked like this. It didn't have that equal sign or the right-hand side. So if this was a question 2-3 days ago, how do we simplify it? Yeah, adding becomes multiplying. So we're going to smush this down into 1 log base 2. 2x times x, which we can do in our head, is 2x squared. Okay, so that's the same as what we did before. We just didn't have another side. We need to get rid of the log. What's the only way to make a log disappear? Exponential, so 2 is going to go over, bump the 5 up. So on the left-hand side we get 2 to the 5. On the right-hand side, 2x squared. Okay, so log and the base disappear. This is just an equation. What kind of equation is it? What kind of equation is this? It's just quadratic. How many ways are there to solve a quadratic? What are the 5 ways? Quad formula. Which one would you like to do? I would not want to do quad formula. I'd probably want to do square root because you don't have an x hanging around. You just have that x squared. So first we have to deal with the 2 to the 5, 32. Divide by 2. X squared equals. Ooh, we're putting a square root into an equation. So x equals -4 and +4. But can we have the negative answer? No, because if I were to sub it back up here, we're going to get log of -4, or over here we're going to get log of -8. Either way, cross it out. If you didn't show me that, if you just went x squared equals 4, I don't know, did you know there was a negative and you knew to cross it out, or did you even not remember that there was a positive negative? If you have it here and then you just have the 4, that's fine. But don't just show me 4 even if you know you have to cross it out, because I don't know if you knew that or did you not know what's going on. So we put them both and we cross out the -1. What do we call this -4? See, now someone's going to think miscellaneous root. No, extraneous root. How are we feeling so far on these? Yeah, they're fun because they're going to work the same way every single time. Okay, look at this one. 2 log x minus log x plus 2 equals log 2x minus 3. Okay, we have brackets. Clearly we want to get rid of them, so I'm going to multiply this log through. No, was that our step 1? No, can we even do that? Resist the urge to get rid of the brackets, because that's what your brain is going to want you to do. It's going to want you to multiply through that log. If the log is, the binomial is behind the log, no touchy. Okay, so we're just back to step 1, which means logs on one side, anything without a log on the other. So our 2 log x is going to stay on the left. Our negative log x minus 2, x plus 2 is going to stay on the left. What's going to happen to our log 2x minus 3? Just come over so he becomes negative. What's on the right? 0. Okay, so that's step 1. Logs onto one side, everything without a log onto the other. Step number 2. Simplify. Okay, we start with coefficients. So I have a 2 right here. Where is it going to go? Okay, anything negative is going to go to the bottom. Anything positive is going to go to the top. So I'm going to do that all in one step. This will become x squared. Is it on the top or the bottom? X plus 2, top or bottom? 2x minus 3, top or bottom? Common mistake is people want to do something with these negatives. So they'll tend to carry them to the bottom and they'll put negative x plus 2, negative 2x minus 3. Where did these negatives go? They disappear because this is the exponent law that says when you're simplifying, negatives become division. So the negatives don't carry through. How do you know when you're done simplifying? 1 log. Are we down to 1 log? Okay, step 3. Convert to exponential. I don't have a base. Oh, well, base 10. Okay, so 10 is going to go over. Bump exponent up. So on the left, what do I have? On the left first. All this crap. X squared and x plus 2. 2x minus 3. And on the right, okay, so 10 to the 0, which we know is 1, so you can jump right to 1 if you want to. Okay, this equation looks a little scary, but we can handle it. I probably want to get rid of the bottom, so I want to get rid of the x plus 2 times 2x minus 3. How do I get rid of something when I'm dividing it? Multiply. So I'm just going to take the whole bottom and multiply it up to the other side. So x squared stays on the left. Those two binomials move over to the right. And this is actually why we're happy when one of the side is 0, because we know when we get down here it's going to be 1, which makes this multiplication a little bit easier. What kind of equation is it? Quadratic. How many ways are there to solve a quadratic? Which one would you like to do? Couldn't you just? Okay. There are 5 ways to solve a quadratic. Which one would you like to do? None. Well, what do we probably want to do on this side? We probably want to FOIL it out to get rid of those brackets, to collect the like terms, to see what's going on. You sound like a robot. Do you want to bring everything to the left or to the right? Okay, so now I'll ask again, which method would you like to use? Okay, so now we just check. If I put negative 3 in here, no good. What if I put it in here? What if I put it in here? No good. If it's no good anywhere along the equation, it's no good. Goodbye, negative 3. If it doesn't work in any of them, out. What do we call that? Extraneous. So what's the answer? 2. Show me your thumb. I'm getting this, I'm kind of getting this, I'm not getting this, I don't know what's going on. Good. Do you want to pause here, or do you want to do one more? Pause. I think that's a good place to pause too. So when we come back, we're going to finish off the notes. We're going to do a foldable, which I'll explain when we get there. Did you want to do some exam questions, or you want to go right to the homework? Okay. Homework is, the next couple of days is all a worksheet because it's better than the book, so they're actually in the back of your notes.